Java EE support on WebSocket. So here we're going to talk about what is and why WebSocket, and we are going to learn WebSocket protocol. These two topics actually from HTML5 class. HTML5 class has a WebSocket as a topic, and these two from that the same presentation, just understanding what the WebSocket is all about. And then majority of this presentation is how we can use WebSocket over Java EE7 platform. So we're going to see programming model, meaning APIs and annotations, and how we can send messages to all peers, concept of path parameters, encoders and decoders, data type and subprotocol, and how we can configure the endpoint. And we're going to see how we can actually write the Java client code as well. So what is and why WebSocket? If you think about the characteristics of modern web applications, they are collaborative, meaning many participants access the same application. So maybe Twitter is an application, or Facebook is an application where there are many participants into the application. eBay is another application where many participants accessing the same application. So they are collaborating in a sense, and it's participatory content generation. So if you see the value of, let's say, Flickr or Yahoo, or not Yahoo, but the Facebook, or the Twitter, the actual contents are created by the participants, and that's the value of those applications, right? So participants post contents. And real time, so contents are published and distributed real time. Again, Twitter and Facebook's are primary applications. And multi-device and mobile friendly. So your applications are accessed through many client types. It could be desktop browser, or it could be tablet, it could be mobile devices, or it could be TV and things like that. So these are the characteristics of modern web applications. Now, the examples of these modern web applications include online gaming, distance learning, collaborative authoring, auctions, and things like that. Now, in order to build this kind of applications, the features that are needed include reliable communication. So between the clients and server, meaning, by the way, when we say client, we're talking about the browser. Browser to server communication has to be reliable, and it should be real-time, meaning event-driven communication. So whenever there is actually something interesting from the client, it will be sent to the server, and then server should actually propagate it to all other participants. Okay, so there is no latency tolerated. Whatever things happen, that should be propagated to everyone involved. Bidirectional communication. So bidirectional communication is that the communication should happen client and server and client at the same time. Okay. Traditional HTTP model is unidirectional, right? Okay. Again, minimum latency and minimum overhead. So these are all requirements that these applications need from the platform, underlying platform. Now, the HTTP in its current form does not actually does not satisfy these requirements. First, it is half duplex, meaning traffic flows only one direction at a time. So if traffic goes from the client and server, then server cannot actually send data to the client at the same time. So it is only half duplex. And it has high overhead. So header data is sent with HTTP request. Each HTTP request and response is huge. You're talking about almost like 800 bytes or something like that for each request and response. And that is just too much overhead. And it is slow, higher overhead, mainly because of the overhead, which means the actual data transfer rate is certainly something to be desired. Higher overhead results in slow communication. and it requires complex hacks to achieve real-time bidirectional communication. So we actually talked about server-side push yesterday a little bit, right? Comet or server-side push, Ajax push, and things like that. You can think of Comet as a hack because HTTP does not really support this event-driven model from the server to client, right? So in this case, client either has to poll or it has to use the long polling, which is actually Comet or Ajax push kind of technologies. So we need something better. So complex hacks to achieve real time is again Ajax, the polling or long polling. So this is something we talked about yesterday, right? So it is possible to have this kind of behavior, meaning server to client event-driven communication, but that requires quite a bit of hacking, as we learned yesterday, okay, through Comet. So we need a better platform other than over the HTTP, meaning we need to have a better platform, communication platform than HTTP. So that's basically what WebSocket is all about, okay? So WebSocket provides full duplex bidirectional communication channel over a single socket, okay, over a single TCP connection. So in this case, both client and server can send data at any time and at the same time. Okay, so it solved the problem of HTTP, half duplex, and the one direction communication problem. It has much lower overhead. So data is sent without the overhead of these HTTP headers. Okay, so in fact, the minimum number of the system data that you have to send is like 4 bytes. So if you compare 4 bytes versus 800 bytes, that is a huge saving. It works with the firewalls and proxies. So initially it will use HTTP for handshaking. Okay, so it should actually work with existing firewalls and proxies. And because it's working with HTTP in the beginning, it integrates well with the cookie-based authentication. So it replaces Comet. Comet, as I said before, is considered as a hack because of the limitations of HTTP protocol. So no more complexity is needed for server sending data to the client whenever it wants to. And it also is capable of what is called the cross-domain capable through CORS. CORS stands for the cross-origin resource sharing. Is the W3C standard for the handling this single origin policy problem. Okay. So it is secure. So WebSocket support. If you actually go to caniuse.com, you can find out so let's go to caniuse.com. You can find out the support level of this the WebSocket. So you can see Firefox is supporting from 28 to 32. Chrome has been supporting from 31 to 37. i10 and 11 is supporting WebSocket. These are the mobile devices. Okay. So in terms of support level, we're talking about 73.88%, meaning close to 74% of the browsers that are being used out there support WebSocket. So it's actually reasonably well supported, the HTML5 technology in browsers. Okay, so let's take a look at let's do the exercise 1. So here we are going to compare WebSocket and HTTP performance. So, basically we are actually doing the same thing. One is doing HTTP REST and the other one is WebSocket. And we are going to send, some size of the data 10 times, and we are going to actually see a performance difference. So let's take a look at the WebSocket exercise 1. So let's import all this project. So I am going to, so try WebSocket versus REST. So let's run this application. So payload let's actually make a payload size maybe 5 bytes, and I will try 10 times. Okay, so we're going to actually try both REST and WebSocket. So REST is going to use just HTTP, and WebSocket is going to use a WebSocket protocol. So let's try this. And now you can see sending 5 bytes of the data 10 times. REST takes about 221 milliseconds, while WebSocket takes only 30 milliseconds. So you can certainly see the performance difference. Okay. All right. So I'm going to actually continue. To the next topic. So let's talk about the WebSocket protocol. So WebSocket connection establishment is done through the HTTP. So connection gets established by upgrading from HTTP to WebSocket protocol using the same TCP connection. So in fact, the protocol of WebSockets and secure WebSockets are starting with this. WS:// and WSS://. So in your client application, when the WebSocket client application needs to communicate with WebSocket server, this WS and WSS, the address will be used. So as I said before, WebSocket has a very low overhead compared to HTTP. So each message is called a frame, has only 2 bytes of overhead for messages whose length is 126 bytes and under. Okay, so you're talking about quite a reduction in terms of overhead. Okay, there is no latency in establishing TCP connection for each HTTP message. So reducing basically 100 milliseconds to 50 milliseconds. There is no polling overhead involved because client and server can send messages to each other direction at the same time. Okay. So this is the request header. So we are going to actually capture this traffic using Chrome developer tool. So this is the first handshaking. So client will send to the server this HTTP message indicating I want to upgrade to WebSocket. And then so you see upgrade, and then you say upgrade WebSocket here, and then you see a bunch of WebSocket secure WebSocket fields. Okay, and you also see cores, the origin field. Okay, so if you don't understand what I'm talking about, this origin field, don't worry about it. Okay. And this is the response from the server. So this basically indicating that the server says, oh, I can actually support WebSocket. So from the next communication, let's use a WebSocket communication protocol. Okay, so that's basically what's happening. All right, in terms of data frame structure, this is what is used underneath. So is fragment bit indicates if this fragment is a final fragment or not. Okay. So the first bit is fragment, is indicating whether this particular fragment is last fragment or is actually part of the big fragment in terms of the data. And then it has the 4-bit opcode. The 1 means it's a text value, 2 is a binary, and 8 means close, and 9 and 10 is ping and pong. Ping and pong is just to see whether its communicating partner is alive. Okay, and is masked bit indicates if this frame is masked or not. Okay, yeah. So don't worry about this mask things. It's actually related to some kind of security stuff for web protocol. I think behind the story was that when WebSocket was designed, without this mask, there was some actually security paper indicating that without a little bit of some masking, there will be some security problems. So WebSocket designers to add this mask field. Okay, so it's for now just consider this is the security related things, and then there is the data. Okay, so exercise 2. So exercise 2, we are going to in fact perform WebSocket operation to existing WebSocket service on the net. Okay, and we are going to observe the handshaking. Okay, So I'm going to actually use this guy. I'm going to actually use Chrome because I want to use the Chrome developer tool, even though you can use a Firefox developer tool as well, Firebug. Okay, so we are going to run the WebSocket Echo application. Okay, so we are going to run WebSocket Echo. So run that application, WebSocket Echo. So this is a client application talking to Echo WebSocket service out there on the net. Okay, so we're going to actually run it. Okay, now it's actually talking to the web server. So if I actually press it, it will, oops, undefined. What's going on? Okay, now it works. Okay, so press it. Why is undefined? Oh, okay. So yeah, it's actually sending it to WebSocket. This is not it. This is. Yeah, so we are actually talking to a local server. It says a WebSocket Echo. Maybe that is the URL I should use. Oh, this is right. Socket Echo. Yeah, okay. So let me see whether it's actually deployed on the server first. Yeah, so it is deployed. So let me actually remove them all and deploy it again. Yeah, so in HTML5 WebSocket presentation hands-on lab, we're actually using the server-side Echo. If this one doesn't work, then we'll try that. But let me just Maven install. And run as on the server. Finish. Yeah, it is WebSocket. Oh, why it's not working correctly? And frame WebSocket undetect response 44. Ah, okay. So looks like a URL is somehow incorrect. Let me see if this is the endpoint issue. Ah, okay. We have some. Why is actually what? All right, so let's actually try this. Okay, so we're gonna actually go to Internet Echo Service WebSocket. You can just Google it, WebSocket Echo Service. Okay, and then you're gonna actually see this Echo Test application. From yeah, so WebSocket websocket.org. So this is basically we can connect to it. So let's get connected right now, and I can send some messages. So I can say JPassion.com, and then send the messages like this. So it responds back. Okay. So we should be able to actually, we'll disconnect first, and we are gonna now observe the traffic. Okay. So I want to actually have it here. Yeah, okay. Here we go. So I'm gonna actually connect. So you can see connection is made, and now you can see the traffic. So here is actually connection upgrade right here. Okay, and then upgrade to WebSocket. And this is response headers, and response headers from the server indicating, yeah, it can actually handle the WebSocket, so it upgrade WebSocket as well. Okay. Now, whenever I send the data, so I'm gonna say JPassion.com to send the data. Now you can see the frame. So this is the data that is actually being sent. So I'm gonna say this time Sang Shin send it, and the data probably send. Okay, so okay, so I have to actually press it again, and then yes, so I have to select this one again to capture the data. Okay, so I'm not sure why the local server application echo is not working, but for now, for this exercise, I want you to just Google WebSocket test, or you can go to websocket.org and /echo.html. Okay, and then you can capture the traffic. Okay, all right. So I'm going to explain the code first, and we're going to actually talk about this one in a bit more detail. On the server side, you are going to use @server endpoint annotation and specifying the address echo, and then you can just have onMessage annotation method, and basically whenever there is a message coming from the other end, this echo method and method that is annotated with this onMessage will be invoked, and this is the message coming from the client, and it just return. Okay, this index.html file, yeah, this is a JavaScript code. So basically the client side has onMessage method, and it's just writing received, and when there is an error, it will actually call onError, and whenever there is actually connection is created, then it will call on open. Basically what happens is this, what's important is this. So it's going to, yeah, first of all, the URI. So this is a URI connecting to the server. You can see this is WS : and then the URI, and then we're going to create the WebSocket JavaScript object, and then for that JavaScript object we are associating event handler. So for on open event, we are associating on open function, and on message event, we are associating on message event handler. On error, we are associating on error JavaScript function. Okay, and you can take a look at you can modify the code on the server side. So you can just instead of just returning message, I want to send the date of today as well. So here when you build and run the application, now you should see this hello socket things as well. Okay, so I'm going to give you guys another 7 minutes to do this exercise unless you guys are done. Java EE7 server-side programming API. So these are the main classes. The session represents the active conversation over WebSocket. Endpoint is used only when the endpoint is created programmatically, and it's basically intercept WebSocket lifecycle events. And remote endpoint is representing the other end of the conversation. So on the server side, remote endpoint means the client. Okay. On the client, remote endpoint means the server. Okay, and then there are message handler. So it's used only when message handler is created programmatically. So again, it handles all incoming messages for an endpoint. So programming model is very simple, as you are going to see in a few seconds. The messaging payload could be text or binary, one of those two, or it could be just ping or pong message. Messaging could be done synchronously or asynchronously, and the whole message or sequence of a partial message. It could be a single message that contains whole message, or it could be the fragment of a big message. And there is no delivery guarantee on this one. So if you want the delivery guarantee, then there has to be high-level protocol to be built on the top of it. Meaning WebSocket itself does not support the delivery guarantee. So this is how you're going to build WebSocket server. So you're going to create the endpoint class, and you can create programmatically or annotation based. And annotation based endpoint using @server endpoint annotation is much more popular. And then you implement the lifecycle methods of an endpoint. For example, onMessage method for receiving the message. And then you add business logic to the endpoint, and then deploy the endpoint inside a web application. So this is the programmatic endpoint. In that case, you are going to extend endpoint class. Okay, but again, programmatic endpoint is rarely used, so we're going to actually mostly focus on annotation-based endpoint. So here, this is the endpoint annotated with the server endpoint, and this is the URL. And then these are the lifecycle methods. So when the WebSocket is created or established, this method gets invoked. When it's closed, this method gets invoked. When there is an error, this method gets invoked. When this is probably the most important, the lifecycle method. When there is a message delivered from the other end, this onMessage method gets invoked. Okay, and this is a message that was delivered from the client. Okay, so in this case, if you want to actually send it back, okay, you get from the session, you call getBasicRemote, and this is they're basically getting a remote endpoint. So if this is a server-side code, right? So this is going to getBasicRemote will return remote endpoint object, which is representing client in this case, and then you are sending send message. So it's basically echoing back to the client. Sending and receiving messages and ping pong. So WebSocket endpoints can send and receive text and binary messages. And so again, you are going to use session and remote endpoint object to send messages to the connected peer, meaning the other side, and use onMessage annotation to receive messages. And the endpoint can also send ping frames and receive pong frames each other. So let's see how you can send the messages. First, you are going to get a session object. So session object is going to be available as a parameter in the annotated lifecycle methods of the endpoint, meaning session object will be created by WebSocket runtime and will be given to you. And then you're going to use a session object to obtain remote endpoint object. So you're going to call session getBasicRemote method, and if you want to actually have async operation, then you're going to call getAsyncRemote. Okay, so for getBasicRemote method will return remote endpoint and basic object, and for async it will return async object respectively. So this basic interface, this is going to provide a blocking method to send messages, and this one is going to provide non-blocking method. Okay. And then you're going to use either remote endpoint object, basic or async, to send messages to the peer. Okay, so sending messages. So this is basic and send text or binary data, and this is for sending ping and pong frames. Okay, so this is an example code. So here, in order to send the messages, basically I get the remote endpoint object .basic, and then I call send text, and this is the text message. This is receiving messages. So basically I have onMessage, and I could actually receive text message, or I could receive binary message here, byte buffer, or I could receive pong message. So depending on what is the type of the message you receive, you might have 3 different onMessage handlers. Okay, so that is a case that you are actually sending data to your partner, meaning communicating partner, right? Now, as I said before, WebSocket is used mostly when you want to send the messages to all participants. Okay, so in this case, server side sending messages to all peers. So when this server is actually being connected by many clients, let's say 50 clients, and if you want to send the messages to all these 50 clients, so like a chatting application, a chatter post a message to your server-side endpoint. And your server-side endpoint obviously wants to propagate that posted message to 50 clients immediately, right? So that is how we can actually do this in this code. So the steps sending messages to all peers. So basically, what you can do is from the session you can call get open sessions. So get open sessions is going to provide a session with each of those clients. Okay, and basically you are going to send the message to all these 50 sessions, meaning all those 50 clients that are represented by each session object. Okay, so you're going to use a get open sessions, and it will return you all the sessions representing all those communication with those clients. So again, these are used when you're building chat application or online auction application or online gaming application and things like that. Okay, so exercise 3, we're going to actually try the chatting application. So let's try exercise 3. So this is chat application. So let's run. Let's just make sure the install is done. And on server and finish. So this is chatting application. So Duke1 is going to join and then send the message, hello, 1, join. Okay, again, we want to simulate another user, so I'm going to open Firefox, and then I am going to say this URL, and then here I'm going to join as a Sang. Okay, so Sang has been joined. Oh, looks like I say Duke. Okay, so I'm gonna actually join as a Sang. Okay, join. So Sang is joined. So the first user knows that Sang has joined, and then you're gonna actually send a message. Hello. Oops. Hello to and chat. So message is sent and message is sent. Oh, looks like this is considered as undefined user, so I need actually yeah. So I'm gonna send from here. So hello 5 chat. Okay, and all the users should actually see the message, including this user. So that is a chatting application. So if you take a look at the chatting application, so this is what we just did. So we have a chat server endpoint, and the only thing we do is basically on message method, and we are just kind of get all the sessions and send it back, okay, to all those clients, right? Okay, so exactly the same code we have seen, and and this is the index, the client side. So we have join function and the send message function. These are all JavaScript code. So this is the WebSocket.js file, and we have a join function and send message function. Okay, and when this JavaScript, when the client is actually when the browser gets started, it is actually making a connection, WebSocket connection, and then basically setting the event handlers to that WebSocket object that was returned. Okay, so pretty straightforward code. Okay, I'm gonna give you guys about 7 minutes to try this exercise. Well, I'll give you 10 minutes, and if you guys can actually finish that up earlier, then we'll continue. WebSocket in Java E7 server-side path parameters. So we have seen how this path param annotation is used in RESTful-based endpoint, right? So it works exactly the same. So if the chat rooms and slash, and that is the variable, that could be captured as path param. Again, we are going to use path param, and this should be the same name, and we capture that as the room name. So works exactly the same as path param in JXRS. I'm going to actually continue. Actually, I'm going to explain exercise 4 first, and then I'm going to move forward with the presentation. Then I'm going to give you guys time to do exercise 4 and 5. Okay. All right. So let's take a look at the exercise 4. This is path prime. So here we are going to run the code, and you can see we are sending the data Duke. Okay. And so we're actually sending the greet/Duke. Okay. And then basically on the server side, we are going to receive it, and we are going to take it as the name, and then we basically return the name. Okay. So I'm not sure where this payload is coming from. Yeah, so this is the client side code. Okay, so yeah, you're adding age. Yeah, so in this case, we are going to send the age and name. So basically, we are going to say greet, Duke, and age. Okay, and it just should return hello, Duke is 23 years old, something like that. Okay. So yeah, I'll give you guys about the 5 minutes to try this exercise. Now we are going to see how we can attach encoders and decoders on the server endpoint. So what is an encoder and decoder? So basically, encoder and decoders are the providers. Is actually a converter between the messages and Java type. Okay, so you can think of them as like a data binder or a marshaller or unmarshaller. So an encoder takes a Java object and produces a representation that can be transmitted as a WebSocket message. So for example, encoder may produce JSON or XML or binary representation. Decoder performs a reverse function. It reads a WebSocket message and creates a Java object. So as was mentioned, WebSocket can actually send only text data and binary data, right? So what you want to do is when you want to actually send JSON or XML, you could actually send it as you can actually have this encoder and decoder that actually converts into for example, on the client side, it will convert to text, and then on the server side, it will receive the text, and then it will send. It will create maybe JSON object or the other Java object and stuff like that, and simplifies the WebSocket applications because it decouples the business logic from serialization and deserialization of object. Okay. So if you have a special deserialization, serialization and deserialization, custom serialization and deserialization, decoder and encoder, encoder and decoder are the one that you can build and plug in. You can have more than one encoder for text messages and more than one encoder for binary messages, meaning you can have multiple encoders connected to these messages, text messages and binary messages. So steps for implementing encoder. So basically you are going to implement one of the following interfaces. Your encoder class will implement encoder.text and the type, and encoder.binary for type for binary messages. And add the names of your encoder implementations to the encoder's optional parameter in the server endpoint annotation. So you have to configure your encoder and decoder to your server endpoint configuration annotation. So we'll see example of that. And then you're going to send object and object data method of the remote and basic or interface to send your object as a message. So you have a Java object and you want to actually send it as, for example, like a JSON or things like that. Then that's the encoder and decoder will actually plug in and will do the work. So container will look for the encoder that matches your type and use it to convert the object, Java object, to WebSocket message. So this is an example of implementing encoder. So first we have to create encoder class. So we are going to create, in this example, message a text encoder. Implements encoder text message A. So message A is basically Java type. Okay. So here we are going to have encode method implemented, which is actually from encoder the text. So we are converting message A Java object into a string. Okay. So in this case, we might convert it into JSON string or XML string or whatever string. Okay. And in order to plug in this encoder on your server endpoint, you have to specify encoders. So, I might have the message A text encoder class and message B text encoder class. You can have, in fact, multiple. So what it does is that, whenever there is a message A being delivered, it will use this encoder class to convert it into a string. Whenever there is a message B object is being sent, it will use this encoder to convert it into a text. Okay, and then you can send a message. So basically, you are going to say send object. Okay, and this message A is a Java object. Okay, and because we have a message A to text encoder, that encoder will be used to encode, meaning it will convert this message A object to the string. The same thing for this. Same thing for the message B. Okay, object. The implementing decoders work pretty much the same. So we are going to implement decoder.text and decoder.binary, and again, you have to configure these decoders to your server endpoint. Okay, and in this case, use the on message annotation in the endpoint to designate a method that takes your custom Java type as a parameter. Okay, so let's see an example of that. So again, we implement decoder class, implementing decoder.text. Okay, and then we have a decode. Message decode method, which take the string, and then it will create message A or message B. Okay, and this one it can also have a method called the will decode or not. So if the data that is coming from the other communication end is a string, it will see. You can call whether this will decode into a particular object. Okay, so that is the decoder, and again, you can configure the decoder on your endpoint. Okay, and then define a method in the endpoint class that receive the message. So this guy will receive the message, right? And then you are going to see whether that is an instance of message A or message B. This is endpoint decode. Yeah, so in this case, define a method on the endpoint class that received the message. Yeah, so this is the message is actually received as a message type, and then we can actually compare that guy as a message A object or message B object. But I'm actually trying to figure out whether how this message type is actually being passed. Okay, so that's something let's take a look at in the hands-on lab exercise. Okay, so that is exercise 5. So let's take a look at the exercise 5. So we have a WebSocket encoder app, and here we are sending you're gonna just send some JSON like this. Okay, whatever JSON the string that you want, and then you say echo JSON, and is sent and received. This is what we are going to see. So let's just make sure that works. Encode. So here I'm going to say and class and Java EE6, something like that. We're going to just send one. Okay, so this is returned. So let's take a look at the code. So here we have configured. So this is the server side. We have configured the message encoder class and message decoder class. Okay. And on this endpoint, okay, yeah, sure. So this is the on message. So this my message should have been converted by the decoder. Okay, so that's the So in this presentation here, by the time you actually receive the message, the decoder should actually have this guy create message object created and send it to you. Okay. So basically, idea is that on your message you can actually receive any Java type of your choice, as long as you have a decoder that actually decodes the string into and convert it into this message object. Okay, and this is the encoder. So this is encoding JSON object to string. So here my message. You receive the my message from the my message, and then we just convert it into string. Okay, so from the my message we call get JSON object, and then we string. And this is the decoder, and decoder you receive the string, and then you're creating my message. Okay, that's the reason again, on your on message you can actually receive it in the form of my message Java type. Okay, so again, the key point is that you can receive in any Java type of your choice, as long as you have the encoder decoder that can convert the string into your Java object. Okay. All right, so I'm going to give you guys about 60 minutes to try this exercise. Okay. Next topic is how to send binary data. So this shouldn't be there. Yeah, that's my mistake. So basically, binary data is you can send binary data in the form of byte array or byte buffer or input stream. Okay, so that's what I actually meant to say on the slide. So this is the server endpoint. It's actually receiving binary in the form of byte array or byte buffer or input stream. Okay, and so and then this is the client side. Client side will actually get the byte buffer and wrap and get bytes, and yeah, so this one is actually using the Java code. Okay, and it's actually sending binary data. Okay, so I'm gonna just move forward. Okay, so let me actually just run the application, and so binary here, run as, and finish. So I can echo binary, this one, and let me see whether, yeah, so we should be able to let's see. Oh, yeah, so this developer tool cannot actually capture binary data, unfortunately. That's the reason you're not actually seeing anything here. Okay, so that is a problem. Okay. Oh, Y is actually having some errors. Oh, it's already with listener. I should actually have some kind of sysout message to check whether in fact they received or not. So let's just try that. Oh, we actually supposed to send the client. This is the client code. Oh, okay, so this is actually from the what is actually getting called? Yeah, oh, okay, so from web page, index.js page. Okay, so it's calling echo byte array, and that is WebSocket. Yeah, so it should actually display the message on the browser in the console. So let's actually take a look at the console here. Oh, okay. So this message is actually being that on-code typer cannot read length of undefined. Yeah. So this is actually the problem I see actually sometimes in Chrome. Somehow the length property doesn't get actually recognized in Chrome. So in this case, I have to actually use Firefox. So I click echo and then it worked fine. This one worked fine and this one worked fine. So I don't know why this is the case in in Chrome. It doesn't actually recognize the length, this length property. This really puzzled me. Okay, so this is how things worked. All right, so next one. Okay, that is a binary data. Now let's move forward with server-side protocol. I'm sorry, the sub-protocol. So what do you mean by sub-protocol? So WebSocket, you can think of it like a TCP connection, and TCP connection you can build on higher-level communication protocols such as SMTP or FTP and things like that, right? So you can think of WebSocket is same thing as a pretty low-level protocol. On the top of it, you can actually have the high-level protocol. In fact, there are the sub-protocols such as XMPP for instant messaging and POP-sub messaging such as STUMP and AMQP. So these are the, in fact, the predefined sub-protocols that are running on the top of WebSocket. Okay, you can certainly have your own sub-protocols as well. So it's a matter of setting the sub-protocol on your on your endpoint. Okay, so let's take a look at the that documentation. So here, when I run this guy, I'm going to see, it's actually using sub-protocol negotiation. Let's see, let's run. Sub-protocol. Okay, so echo and received. Now, if you actually take a look at the network, see. And the sub-protocol. Oh, this is actually HTTP GET. Yeah, this is not what I want. This is just the refreshing the page, so that's not what I want. I am going to run the application. Okay, oh, it's actually connected. Yeah, so it connected right away. So it should actually be shown in the connection. So now, yeah, it's not gonna actually. Yeah, refresh probably doesn't work. Let's try. Yeah, so the point is you should be able to actually capture the traffic. So let me see whether I was able to capture. Okay, so endpoint. Oh, okay, so this is actually endpoint thing. Yeah, okay, so that's actually, I should actually do this guy. Okay, so here you can see my protocol. So this is the your sub protocol. Okay, so client says, I want to actually run sub protocol on the top of WebSocket called the my protocol, and the server says, yes, I can handle it. Okay, in fact, the client could actually specify set of multiple protocols, and then server can actually choose one of those high-level protocols. Okay, so that is a sub protocol. In the future, there could be, in fact, a lot of sub-protocols. In the same way, there has been a lot of, let's say, TCP IP protocols on the top of TCP IP. For example, SMTP, FTP, many, many protocols, right? So those kind of high-level protocols could be built on the top of WebSocket. So that is the idea. Okay, so that is sub-protocol. Moving forward. At server-side endpoint configuration. So, we have already seen one server-side endpoint configuration, which is the sub-protocol. So you can actually have a custom endpoint configuration logic. One of the things is, in fact, the sub-protocol, as I mentioned before. So access the details of initial HTTP request for a WebSocket connection. Perform custom checks on original HTTP header. Handshake response, and choose the WebSocket subprotocol from those requested by the client, and control instantiation and initialization of endpoint instances. So you can do a lot of customization on your endpoint. So let's see the things you can do over here. So I actually have, in order to actually have configuration, you have to create a class that extends server endpoint config.configurator. So I have a custom configurator, and in this case, what I want to do is, before my endpoint actually receive the request, I want to actually change the request and response. So here, I have a configuration, get user properties, and put handshake request and request. So basically, I'm actually adding another in this case properties, and then I am going to configure this custom configurator on my endpoint. So here I say configurator equal custom configurator, and in this case, my endpoint, when it is opened, I should be able to get some kind of user properties that was set. Okay, so whatever you want to actually set here, I can actually get it from the user properties configured in this configuration object. Okay, so that is endpoint configuration. That's exactly the code. So it's endpoint configuration. So echo, and then what you're going to see is this like header things is actually being displayed, and so on my endpoint I have what is called the my configurator class, and my configurator class again extends server endpoint config and configurator class, and here I can do anything I want. So basically I'm just displaying this handshake request, serving it, and blah blah blah, and then I'm just getting these headers, just displaying these headers. Okay, yeah, so I get the get headers, key set, and display these headers. So basically what is being displayed is connection upgrade, sec socket upset, and upgrade. So these are the headers in WebSocket request, right? Okay. So that is a configuration. Last one is a client-side API. So typically you are going to use JavaScript, the client, in which case you are using JavaScript-based client API, but Java also provides a client-side API. So if you are writing WebSocket client code in Java, then you can use this client-side APIs defined. Okay, so let's take a look at the exercise 9. And so here, this is remote endpoint is the WebSocket.org echo point, and this is the one that we have deployed. Okay, so when you run the application, and so this is a client code. So client code is basically you are going to get the WebSocket container, and you create the URI, and then you create the connect server. Okay, and then you are going to use the client endpoint annotation, and then you have this lifecycle method on your client side. Okay, so this one is this is actually, yeah, so we have a client code in the form of the servlet. Okay, so servlet will actually send this, the client class. Okay, so it create the container, and then create the URI, and then container connect server. So this is actually my client is basically the client endpoint. So that's basically what I have here. Okay, so let's run the client side. So this is the web application run on the server. Finish. So you can actually use the remote endpoint that is actually sending to WebLogic, the WebSocket.org /echo HTML, and this one is the talking to your local endpoint. Okay, so I'm gonna actually try this one. And then you can actually see server the log for log messages from message exchange from client and server. So you can certainly find out the these are the messages. Okay, sending messages. Wait a minute, is this the right one? So I'm gonna just log file. Yeah, okay, so that seems to be the, yeah, it's just sending. So let me just clear this guy, and we'll just try again. So refresh, and let's see what that. Yeah, so I don't know why this illegal state exception things. Yeah, so these are the messages actually coming from the code. Okay, let's see. If I do remote, let's see whether I'm gonna actually connect the remote. Okay, so it's actually getting connected to echo websocket.org and 80. So in this case, yeah, so we have a few more messages. So let's clear this guy, and I'm gonna actually try to this guy one more time. And yeah, so connected to the endpoint, sending message to endpoint, and receive the message. These are all messages coming from the client side. Okay, so that is the client side code. If you take a look at the client side code, yeah, so receive messages. Okay, and my client. Okay, so sending messages to endpoint, and when connected, what is it connected? Yeah, so connected here on open. Okay. All right, so that is the end of the presentation. So let me just finish up the presentation.